In this problem, we'll look at the sum from n equals 1 to infinity of n over n plus 1 all to the n squared power. The n squared power indicates that we should think about using the root test. So remember, for the root test, we need to look at the limit as n goes to infinity of the terms of our series. So in this case, it's n over n plus 1 to the n squared, all to the 1 over n power. So we remember that our exponents multiply here, so we get limit n goes to infinity, n over n plus 1, and then these exponents multiply, so n squared times 1 over n just gives us a single n. Now as n goes to infinity, n over n plus 1 goes to 1, and then our exponent n is going to infinity. So this looks like 1 to the infinity, which is one of our indeterminate forms. So this is an indeterminate form, which means eventually we'd like to be able to use L'Hopital's rule. But before we use L'Hopital's rule, we need to get our expression in the form 0 over 0 or infinity over infinity. So our technique, remember when we have n's both in the base and in the exponent, our technique is to say, okay, let's call this limit we're looking for L. So L is the limit as n goes to infinity of n over n plus 1 all to the n. And then to get this n out of the exponent, we're going to take the natural log of both sides. So we get natural log of L is the limit as n goes to infinity of the natural log of n over n plus 1 to the n. And now remember that the natural log of a to the b, that's just equal to b times the natural log of a. So the exponent pulls down, which is why we did this, so that n is going to pull down. So we get limit n goes to infinity, n times the natural log of n over n plus 1. Now let's think about what we have. We said n over n plus 1 is going to 1. So this guy is going to natural log of 1, which is 0, and then n is going to infinity. So we have infinity times 0, which is still not 0 over 0 or infinity over infinity. Remember, we need one of those two forms before we can apply L'Hopital's rule. So we're going to take our n in the numerator and rewrite it as a 1 over n in the denominator. So n in the numerator is the same thing as 1 over n in the denominator. Now the top is going to log of 1, which is 0. The bottom is going to 0 as n goes to infinity. So now we can apply L'Hopital's rule. So now we get the limit as n goes to infinity. The derivative of the top, so we get 1 over n plus 1, so that fraction flips and we get n plus 1 over n. And then the chain rule says we have to multiply by the derivative of the inside. So we get the derivative of n, which is 1, times n plus 1, minus the derivative of n plus 1, which is 1, times n, all over n plus 1 squared. And then we have over the derivative of the bottom. The derivative of 1 over n is negative 1 over n squared. So let's do some algebra to simplify and see what we've got here. So we get limit n goes to infinity. We have an n plus 1 over n plus 1 squared, so one of those is going to cancel. And on the bottom, we're just going to have n times n plus 1 from this guy and this guy. And now on the top, this is going to become, when we multiply out, so we get n plus 1 minus n. So those n's go away, and we just get a 1 on the top. And then the negative 1 over n squared, so a fraction in the bottom flips, and we just get negative n squared. So now we have the limit, as n goes to infinity, of negative n squared over, multiplying on the bottom, we get n squared plus n. Now divide top and bottom by the highest power of n in the denominator, which is n squared here, and we get minus 1 for our limit. But remember, this is not our limit L. We took the natural log of both sides. So this tells us that the natural log of our limit L is equal to minus 1, which tells us that L is equal to e to the minus 1, which is 1 over e. 1 over e is definitely less than 1. Remember, the root test says that our series converges if the limit is less than 1. We got 1 over e, which is less than 1, So this series converges by the root test.